Hi everyone, and welcome to our video on solving trig equations where we need to apply an identity to help us solve. So in this first one, notice we have a mixture of trig functions. In the previous video, I did say we want one side to be 0 if there's multiple trig functions. Well, that's still true on this. So let's first make the side 0. Okay, so one side should be 0 still. Let's add that note here again. Multiple trig functions, let's say multiple trig func, make one side 0. All right, so we would subtract the sine theta over. So we would have 2 cosine squared theta minus sine theta minus 1 equal to 0. Now, here we do have a mixture of trig functions. So I have a cosine function and a sine function. And there's nothing else I can currently do, but I do see, oh, it looks like a quadratic, like we saw, let me scroll, so I kept these, from these videos. So notice these were quadratic formed equations, but also one thing that's very important is that it was a cosine squared and a cosine. So it wasn't a mixture of trig functions, it was cosine squared and cosine. Same deal with number 2, sine squared and sine. So if we have a mixture of trig functions and we currently can't really do anything with factoring, then what we need to do is make them all the same trig functions. So we will apply Pythagorean's identity to help us with this problem. All right, so remember our identities. Let me squeeze those up there too. So our main one is sine squared theta plus cosine squared theta equals 1. But we know we can subtract one of the trig functions over. So for instance, if I subtracted sine squared over, I would have cosine squared theta equals 1 minus sine squared theta. And that's what I want to use on this problem. So I need it all in terms of sine. So I'm taking the square and trying to use an identity. So similar to when we simplified trig expressions, if we had a higher power, okay, so power of 2, we're thinking try to factor or try to use an identity. Okay, so that's what we did then. It's still what we're doing now, except we're solving an equation. All right, so that means that in the blue, let's change it. It would be 1 minus sine squared theta using Pythagorean's identity. The 2 still out front, and then the other stuff's still there. So after the blue, we've got minus sine of theta minus 1 equal to 0. All right, and then now we're going to distribute the 2. So we'd have 2 minus 2 sine squared theta, and if it helps, do the arrows. Okay, so 2 times 1 is 2, and then 2 times sine squared of theta is 2 sine squared of theta. Keep the minus. And then minus sine of theta minus 1 equals 0. And then we can see, oh, this 2 and that negative 1 would become a plus 1. And rearranging, or not rearranging, just keeping it in descending order, I would have negative 2 sine squared theta minus sine theta plus 1. Now it's in the form of those previous trigonometric equations that were in quadratic form. I have sine squared and sine, so now it should factor nicely. Well, one thing you can do, I don't like a negative leading coefficient. I am just going to divide everything by negative 1 to change them, so that way my leading coefficient is positive. So now I have positive 2 sine squared theta plus sine of theta minus 1 is 0. And really, I didn't show it. The 0 also would have been divided by negative 1, but that doesn't change 0. All right, and now it's time to factor. Okay, so we changed it so that we could factor. I'm going to use my strategy again where I guess and check, where I say, oh, something times something should be 2 sine squared theta. The only way to get that would be to have 2 sine theta, leave a space, and sine of theta as those first terms. Okay, so 2 sine squared theta times sine theta is 2 sine squared theta. And then I look at the last term. The last term is currently negative 1. The only way to get 1 is to use 1 and 1. And now my last step is to figure out the signs. Well, it's a negative, so 1 should be plus, 1 should be negative. I believe I should do a minus here and a plus here. All right, and when we double check, notice 2 sine of theta times a positive 1 would be 2 sine of theta, and then minus 1 sine of theta would be positive 2 sine theta, or positive sine of theta. So it does match. And then negative 1 times positive 1 is negative 1. Okay, so that shows that we did it correctly. Remember, if you factor, you can always check by multiplying. Now that we have the two factors set equal to 0, we can split them into their own equations set equal to 0. Okay, and then on this first one, we should add the 1 over. So we'd have 2 sine of theta would equal 1. And then we could divide by 2 to get sine of theta is 1/2. The second equation, it just is subtract by 1. So we would have sine of theta is negative 1/2. And then now we'll use our unit circle. All right, so I'm going to put the unit circle over here. And I'm going to use some colors and say, well, my sine of theta equaling 1/2. So that's the y-coordinate of 1/2 would be close to the x-axis. So that means I know it's the ones with the 6 in the denominator. So pi 6th, 5 pi 6th. And then where sine of theta equals negative 1/2, so a y-coordinate of negative 1/2 is down there where the angle is 3 pi over 2. Okay, so these are the three answers between 0 and 2 pi, and we know we should add 2 pi k to them for our official final answer. All right, so I'm going to squeeze that official final answer in right here. We have pi 6th plus 2 pi k, 5 pi 6th plus 2 pi k, and 3 pi halves plus 2 pi k. Okay, there we go. All right, and like always with any equation, we can double check. If I plug in a pi 6th into this equation, so I'm going to erase this. We'll do this in a different video. My check I am going to erase, so I have space there. But if I'm checking my theta equaling pi 6th, I would have had 2 cosine of pi 6th, and then that would get squared. I'm just rewriting it. Minus 1 equals sine of pi 6th, question mark. So we want to find out if this is true. Well, cosine of pi 6th is radical 3 over 2, and it will get squared, and then minus a 1. Sine of pi 6th is 1/2. Well, radical 3 over 2 squared, each of those gets squared. Numerator would become 3, denominator becomes 4, and then still minus 1. Does this still equal 1/2? Well, the 2 and the 4 here would reduce. It would be 3 over 2. Let's change the 1 into 2 over 2. So that we can see, yes, 3 over 2 minus 2 over 2 is 1 over 2. Okay, so it shows the pi 6th works. We could also try the 5 pi 6th. It will also work. And if we did the 3 pi halves, it would also work. Okay, so you can always double check all of your answers in these trig equations. Okay, but I think we'll pause this one. We'll do number 2 in a different video. Thank you for watching, and I'll see you next time.